Hello, everyone. Thank you for joining our cold stress awareness webinar today. I'm here today with Rick, one of our LSCI safety consultants. My name is Kylie with Lancaster Safety Consulting. We're a nationwide OSHA compliance firm focused on helping workplaces operate safely each day. Through safety and health training, written policies and procedures, workplace analysis and assessments, inspection assistance, and more. We hold free webinars on a regular basis, so make sure to sign up for our webinar alerts if you aren't already signed up. Our goal for today's webinar is for you to have a good understanding of hazards associated with working in cold environments and what you can do to keep yourself safe. So let's get started. Most people don't enjoy working in the cold. It can also come with different challenges and hazards. So, what types of hazards and challenges does working in the cold actually bring?
Yeah, Kylie. So to start off, working in the cold can be dangerous, obviously. It can bring health emergencies for people in different vulnerable conditions, such as lack of shelter, outdoor workplaces, poorly insulated or non-heated workplaces as well. When temperatures do drop decidedly below the normal and wind speed does increase, the heat can more rapidly leave your body as well. So these weather-related conditions may lead to serious health problems, also from that. Cold conditions can force your body to work harder to maintain its temperature. Challenges, that a cold environment can present include the air temperature around you, any wetness, such as rain, snow, ice, humidity. If you're sweating, wet clothes from sweating or that rain, other sources of water. Also, air movement, such as wind speed, any blown air from fans in cold rooms, so on, that sort of thing.
Thanks, Rick. Now let's take a look at body temperature. Most of the body's energy is used to maintain an internal or core body temperature of approximately 98.6 degrees. The body does this through balancing heat loss and heat production. In cold conditions, the body reduces heat loss and increases heat production. Over time, your body will decrease blood flow to the extremities and outer skin and actually shift it into the body core to keep the internal organs warm. However, this allows exposed skin and the extremities to cool rapidly and increases the risk of cold-related injuries such as frostbite and hypothermia.
That's right. Thanks, Kylie. So when your body is faced with extremely cold temperatures, it does automatically respond by increasing the blood flow to your internal organs to keep them warm. But as a result of that, it will leave your skin vulnerable. So let's take a look at this picture. And, it really makes me want to get a heated blanket seeing all this coldness and snow swirling around.
It definitely does.
The wind chill is perceived temperature or what it feels like. So resulting from the effect of wind or wind speed in combination with the cold air or the air temperature. The combined effect increases the rate of heat loss from the exposed skin. So the stronger the wind is at any given temperature, the cooler the wind chill will be outside. For example, let's say the temperature is negative 15 degrees Fahrenheit and the wind speed is 10 miles per hour. Your exposed skin will receive conditions equivalent to the air temperature being negative 35 degrees Fahrenheit, which as a result, frostbite will develop in about 30 minutes. If that wind speed will double to 20 miles an hour, it will feel like it's negative 42 degrees Fahrenheit, and frostbite will occur in only about 10 minutes. If your body begins to lose heat faster than it's produced, then your core body temperature will drop below normal, and then that's when the cold-related illnesses may occur. This doesn't only happen when conditions are below freezing, however, it can also be brought about by temperatures in the 50s, coupled, with some rain and wind and various conditions as well. So let's take a look at this. How does working in the cold affect your performance?
So, working in uncomfortably cold working conditions, such as a combination of temperature, wetness, and wind, can lead to immediate signs of cold stress. So, some of these signs include decreased alertness, restlessness or lack of concentration, impaired performance of complex mental tasks, impaired ability to perform manual tasks, even numbness, muscle weakness, and stiffened joints. This in turn leads to lower work efficiency and higher accident rates.
That's right. So here's a list of factors that can increase the risk of cold injuries and illnesses. In general, people in good physical health are less susceptible to these injuries from the cold conditions. So let's take a look at some of the more common factors. We have fatigue, caffeine use, too much or not enough activity, overall age, dehydration. Specifically, dehydration in particular does cause your body's natural defense mechanisms to fail, and then the person will become more susceptible to cold injuries as a result. Caffeine does increase urine production, contributing to that dehydration as well. Same thing with alcohol consumption. It also will decrease awareness. It'll impair your body's ability to regulate the temperature and does increase the risk for hypothermia.
Exactly. Other risk factors include having previous cold related injuries or predisposing health conditions, things such as cardiovascular disease, diabetes, anemia, and other conditions associated with poor circulation. Poor physical condition, poor nutrition, medication, the length of exposure, not dressing warm enough will obviously put you at higher risk. And also, you can add this to the list of smoking hazards. Nicotine actually increases the risk for cold induced skin injuries. And when it comes down to it, what injuries and illnesses do people get from being overexposed to the cold, Rick?
So, cold exposure can result in different injuries such as hypothermia, frostbite, and frost nip. Hypothermia will occur when a core body temperature drops below 95 degrees Fahrenheit. This can occur in air or water temperatures below or above freezing and can be fatal. Frostbite is caused by ice crystals forming on the skin and other tissues of the body when exposed to temperatures at or below freezing. Frostbite does cause permanent damage and destruction to the blood vessels and other structures and can result in amputation in extreme cases. Frost nip is less serious than hypothermia and frostbite, but ice crystals will form on the very outer layer of the skin and does not cause any permanent damage.
All right, so in a real life situation, would you know how to tell if someone's actually suffering from hypothermia? There's a couple different things to look for: confusion, shivering, difficulty speaking, sleepiness, and stiff muscles.
Yeah, thanks, Kylie. Now that you can recognize the warning signs of the hypothermia, here are the steps that you want to take to treat someone that is showing these signs. First, you want to alert the supervisor and request medical assistance. Next, you want to move the victim into a warm room or shelter. Remove any wet clothing and begin to warm the body, focusing on their core first. So that's your chest, neck, head. Use loose, dry layers of blankets, clothing, towels, sheets, anything you can find. Warm beverages might help increase the body temperature, but you don't want to give them any alcoholic beverages. And you also don't want to try to give beverages to any unconscious people. After the body temperature has increased, keep the victim dry and wrapped in a warm blanket. And you want to make sure to include the head and neck, keep that wrapped up as well.
Thanks, Rick. And redness or pain on the skin is often the first sign of frostbite. Other different signs can include white or grayish yellow skin areas, skin that feels unusually firm or waxy, and even numbness. Always be on the lookout for these signs.
So if you do recognize a frostbite situation, you want to immediately seek medical attention. While you wait for the medical attention to arrive, follow these steps. Move the person into a warm room or shelter as soon as possible. Unless absolutely necessary, do not walk on the frostbitten feet or toes, as this can, only increase the damage done to them. Immerse the affected area in warm, not hot water, just warm. The temperature should be comfortable to the touch for unaffected parts of the body. Warm the affected area using body heat. For example, the heat of an armpit can be used to warm frostbitten fingers if you have no other options there. Do not rub or massage the frostbitten area. Doing so may cause more damage with constant rubbing. Do not use a heating pad, heating lamp, or the heat of a stove, fireplace, or radiator for warming. These affected areas that are numb can be easily burned as a result.
All right, and before starting work in cold temperatures, take time to plan for the work in the cold weather and implement controls to reduce and minimize exposure and the risk of cold stress. During this planning process, you'll want to consider planning for the conditions, engineering controls that might help, different work practices, making sure you're wearing the appropriate clothing, and also personal protective equipment. A key takeaway for today, and for any safety and health training for that matter, is the importance of awareness. Being aware of how your body is reacting to the cold is important in preventing cold stress. It's easy for our minds to get distracted. I mean, I bet during this webinar you've had a few thoughts distract you, and that's natural for all of us. But it can be dangerous when we're working in the cold. We have to be aware of our bodies.
That's right. So when planning for indoor work, you want to keep in mind the following. OSHA does not necessarily require employers to provide heat or air conditioning. However, they do recommend temperature control in the range of 68 to 76 degrees Fahrenheit. Good indoor air quality is also important for worker comfort and health. Employers are, however, responsible for protecting workers from extreme heat and for a safe and healthy workplace overall.
Take readings of temperature and air movement in all cold work areas at least every 4 hours, even indoors. Aim to take the temperature at the start, middle, and the end of each shift.
When you are planning to work outdoors in the cold, the weather report can be used to your advantage as well. If the extremely cold weather is predicted, consider postponing work to a warmer day if possible. Heavy work should be scheduled during the warmer parts of the day as well, if that's possible.
And if there is air movement from the wind, ventilation, or travel in an open vehicle, consult the wind chill index to evaluate the hazard. The wind chill index takes into account the wind blowing the heat actually away from the body. All right, on to control measures. So let's take a look at what control measures to take and in what order.
So when it comes to control measures, engineering controls are always the first line of defense against injury. After eliminating the hazard altogether or substituting with a less hazardous process or substance. When looking at the engineering controls for working in cold conditions, consider the use of radiant heaters, warm air jets, maybe some other heating mechanisms as well. To reduce wind chill, install shields or barriers to shield work areas from any drafts or wind coming in. Provide heated warming shelters such as tents, cabins, restrooms for continuous work in temperatures that are below freezing. Cover equipment handles, especially metal handles and bars, with maybe some thermal insulating material when those temperatures do drop below freezing. Steel conducts heat away even faster than water, believe it or not. Design machines and tools so they can be operated without having to remove gloves or mittens as well.
And on administrative controls. So, administrative controls involve changing the work practices and policies. Providing awareness tools like training are part of administrative controls. You can also implement changing shifts so your team isn't exposed to the cold for too long.
Exactly. So once you've exhausted those two methods, your last line of defense is protective clothing or PPE. It's important to dress for the temperature as well. So to protect your body, hands, feet, your head when working in cold environments, you'll want to dress in at least 3 layers of loose fitting clothing to trap air and provide insulation. You want to allow better ventilation as well. The inner wicking layer should be made from a polyester, polypropylene, or other synthetic material that draws moisture away from your skin, helps to keep it dry. The middle insulating layer should be made of wool, down, fleece, or other material with loft that will hold the body's heat inward. And then the outer layer will protect against any wind and water. It should be made of breathable, waterproof fabric that will allow some ventilation, but is also windproof and may also need to be resistant to oils, fires, chemicals, or abrasions, depending on the work you're performing. Any additional layers of clothing should be large enough not to compress any of the inner layers and decrease these insulation properties.
Thanks, Rick. That was definitely helpful. Now, on to hand protection. Gloves and mittens should be worn to prevent cold related injuries as well as preventing accidents and maintaining dexterity. The ACGIH recommends wearing gloves when the air temperature is below 60.8 degrees for sedentary work, below 39.2 degrees for light work, below 19.4 degrees for moderate work, and below 0 degrees, wear mittens, which actually protect you better than gloves. Use gloves and mitten liners for even more protection. Fingerless gloves with mittens can be used for work requiring that dexterity.
Exactly. And as we're coming to a close here, we want to touch on a few items for you to take along with you and remember. Pace your work to avoid excessive sweating. Change into your dry clothes if the clothes you're working with become wet. Avoid sitting or standing still for any prolonged periods. Take frequent breaks, however, in shielded areas out of the cold to reserve your energy. Work in pairs to keep an eye on each other. Use the buddy system. Watch out for signs of cold stress. Consume warm, high calorie foods such as pasta and those carbs to maintain energy reserves. Drink plenty of warm liquids often to prevent dehydration. When it is cold, though, do not brush up against metal surfaces with your bare skin. The skin may stick to them and get immediate frostbite. Greases and oils also get thick and hard which makes equipment difficult to be using. Follow the proper procedures and use the right tools. Tools also can get brittle in the cold, so use caution when working with them. Avoid any skin contact when handling evaporative liquids such as gasoline, alcohol, cleaning fluids, that sort of thing. While de-icing and fueling below 40 degrees Fahrenheit, these materials I just mentioned in contact with the skin can greatly increase heat loss from the body as well.
Thanks so much, Rick. And that's all we have for you guys today. Thank you so much for joining us. We'll actually be emailing this cold stress toolbox talk as follow up to the webinar.
Yeah, no problem, Kylie. Some good information in this one. If you do have any questions, missed a link, or anything you're interested in and would like to set up that free phone consultation, definitely give us a call at 888-403-6026 or send us an email at safetyquestions@lancastersafety.com. Thank you for attending today and stay safe and keep yourselves warm.